Welcome to this video of our hybrid terrain generation project. In this project, we built a Unity-based framework combines multiple noise-based techniques like Perlin Noise, Fractal Brownian Motion, and Voronoi-based biome partitioning to generate terrains that are not only realistic, but also visually diverse. These terrains are further enhanced with the help of Cellular Automata rules, which systematically populate the environment with plants, rocks, and other natural features. In addition to that, we've integrated an AI layer that brings the environment to life by simulating predator-prey dynamics. Using finite state machines in Unity's net mesh system, we introduce simplified food chain interactions to create a dynamic and engaging ecosystem. In this video, we will go through a list of features in this project. As you enter the interface, you'll be able to view the terrain with flexible camera controls. Using the mouse, you can zoom in, pan, and adjust your view to visualize the terrain in detail. Pressing the F key resets the view to the default position. Next, you can change the terrain settings. Let's start by selecting the forest terrain. We'll first interact with the Perlin Noise panel, where you can tweak the parameters to adjust the terrain's features, such as its tendency or roughness. You'll see the terrain update dynamically as you modify the settings. Now, let's move on to the FBM panel, where altering parameters like the layer count provides additional detail and variation. You can use the camera control to examine these changes up close. For midpoint displacement, you can overlay this algorithm by ticking the Enable/Disable box. Observe how the terrain evolves as you toggle this option. This feature is available for other algorithms too, which allow you to explore their effects. If you input a value outside the reasonable parameter range, an error message will appear on the panel above the terrain to guide you. As you can see in the Voronoi Biomes panel, you can choose between two distribution modes in the toggle: grid or random. These options control how objects are spawned across the terrain, offering flexibility for different design goals. The lake and trail systems provide additional layers of visualization and realism. These features can be toggled on and off, and their parameters can be customized to create unique terrain features. When you want to switch terrain types using a toggle, all previously entered settings and inputs are preserved and applied to the new terrain. The Cellular Automata feature lets you adjust parameters like neighbor threshold, which controls the spawning distance between objects, and global density, which affects object population. These settings allow for precise customization of the terrain. Finally, the most exciting part of this interface, AI agents. Once your terrain customization is complete, you can enable AI agents by baking the net mesh. These agents, represented by colored spheres at this stage, interact dynamically within the terrain. Keep in mind that every time you update the terrain or change parameters, you'll need to click the Bake Nav Mesh button again to reflect the latest updates. Thank you so much for watching. We hope you enjoyed exploring it with us.